Hello Math 3 students and welcome to your 4.1 video. So for the 4.1 tasks, it says one of the most interesting functions in mathematics is f of x equals 1 over x because it brings up some mathematical mind benders. In this task, we will use story context and representations like tables and graphs to understand this important function. Let's begin by thinking about the interval 1 to infinity. So to kind of remind you of interval notation, these are your x values. So when they're talking about 1 to infinity, let's say we're even looking at a chart here, 1 to infinity would be, oops, that actually should be filled in. It would go from 1 all the way here. So those are the x values that we're talking about. All right. It says, imagine that you won the lottery and you were given a big pot of money. Of course, you would want to share that money with friends and family. If you split the money evenly between yourself and one friend, what would each person's share of the prize be? Well, that'd be a half, right? You'd get 1/2 of the prize. If 3 people shared the prize money, what would each person's share be? Well, that would be 1/3, okay? It says model this situation with a table, equation, and graph, all right? So we'll start out, we'll have our number, oh my goodness, of people. And then we'll put their share. All right. So, of course, if we have one person, they're going to get the whole thing. If we've got 2 people, they're going to get half of it. Now, I'm going to start using decimals just because I think decimals are easier to graph. That's me personally. If you like fractions, go ahead and use that. Right? Like that your fraction would be 1/2, which is equivalent to 0.5. Then if we have 3 people, our fraction would be 0.3 repeating. If there was 4 people, we would have 0.25. Oops. And if there was 5 people, we would have 0.2. Okay, so notice what's happening to these numbers as they go down. As the x values increase, the y values are going down, right? It's getting smaller and smaller. And I also want you to keep in mind, well, what equation are we using here? Well, we're actually using 1 over x, right? Our input is our x value, right? And we're just increasing that x value by 1 each time. So if we were to graph this, we'd have 1, 1, 2, comma, 0.5, 3, comma, 0.33. So that'd be about there. And then we'd have 4, comma, 0.25. So you'd go 1, 2.5, and then 5, comma, 0.2. All right. And what ends up happening is this obviously is going to get smaller and smaller and smaller and smaller, right? The more people that you share it with, the smaller your percent, or I guess decimal, of the prize is going to get. However, you could split it up between 1 million people, 1 billion people, but you're still going to get part of it, right? Even if it's like 1/1,000,000 of a cent, you're still going to get some of that prize money. So what happens is this graph is going to approach 0, all right? So for number 4, it says, just in case you didn't think about really big numbers in your model, how much of the pot would each person get if 1,000 people get a share? Well, each person would get 1 out of 1,000, right? If 100,000 people share, well, how much would they get? They'd get 1 out of 100,000. What if 100 million, right? Then you would get 1 out of 100 million, right? And these values, it says, use a mathematical notation to describe the behavior as x approaches infinity. Now, we have talked about, we talked about like end behavior, right? And prior to this, right, the end behavior is either going off to positive infinity or going off to negative infinity. But now let's think about this. As our x value gets larger, what is happening to our y value? Where is this guy going? Well, he's approaching 0. He's never actually going to reach 0, but he's approaching 0. Okay, so your notation for this would be as x approaches infinity, f of x approaches 0. All right. It says, next, look at the interval 0 to 1 and consider a new way to think about splitting the prize. Imagine that you want each person's share to be 1/2 of the prize. How many people could share that prize? Right? Well, if each person wants half, you would end up with 2, right? If you want each person's share to be 1/3, how many people would share this prize? 3 people. So essentially all they're doing is changing the X and the Y values, right? They're giving you the share as your input, okay? And you're telling the number of people as your output. All right, so your share is going to be, right, we'd say share of 1, you'd have 1 person. Share of 1/2, you'd have 2 people. Share of 1/3, you'd have 3 people. Share of 1/4, you'd have 4 people, right? So we could go ahead and we can graph that, right? If we're at 1, we'd have 1 person. If we were at 2, I'm sorry, if we had a share of 1/2, we'd have 2 people. Then we go to 1/3, which is 3.3. So we go 1, 2, 3.3. I'm gonna go up 1, 2, 3. And then we've got 1/4. Which is, I guess actually it's better to think of this as 0.25. Right? So you go to 2.5 and we'd go up to 4. All right. So notice what's happening to this. This one's got this kind of a shape. All right. Now for number 9, it says, what do you notice when you compare the 2 models that you have written? Okay. Well, they are actually inverses, right? Look, our input's now our output. Our output is now our input. They are inverses. All right, so for number 10, it says, create a table for 1/x that includes negative input values. All right, so let's go ahead and try that. We'll say, okay, we'll have our input and we'll have our output, or f of x. All right, our inputs, we'll say -1, -2, 0, 1, and 2. All right, and our equation is 1/x. So for this first one, it's just going to be 1/-2. Then we'd have 1/-1, which is going to give us -1. And then we end up with 1/0. Now, this is a problem, right? We know that we are not allowed to divide by 0. This has a special name in math, and this is called undefined. You are not allowed to divide by 0 in math. So it's actually undefined at x equals 0. Then, of course, we end up with 1 divided by 1, which is going to give us 1. Then we get 1/2, which is 1/2. All right. So for number 11, it says, how do the values of f of x in the interval from -infinity to 0 compare to the values of f of x from 0 to infinity? Use this in comparison to predict the graph of 1/x. Okay, so if we look, all right, for the negative values, look, our answers are negative, right? For the positive values, our answers are positive. So think about this. If you were to write this as a coordinate pair, you have negative, 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 oops, negative. These guys, you'd have positive, 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 positive. All right, and they're asking you to kind of predict. Well, think about the graph. All right, you have 4 different quadrants. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, these positive values are positive, positive. These are where all of your positive, positive people are going to be. The second quadrant's going to be negative, positive. This third quadrant's negative, negative. And this fourth quadrant, I don't know why I keep writing -1. And then this fourth quadrant would be positive, negative, right? So the positive part of the graph is going to be in quadrant 1, right? Because if we look, it's always positive, positive. These guys are going to be in quadrant 1. And these guys, which are negative, negative, are going to be in quadrant 3. Okay? So I guess you could even just say this, right? You would end up having parts of the function be in quadrant 1 and parts of the function be in quadrant 3. All right? So now they ask us to graph, which fortunately we've already, come up with a table. So we could go ahead and kind of steal some points from that. One thing I am going to recommend you do, let's change these values to negative 5, 5, 5, and negative 5 here. It'll make our lives a little bit easier. And I am just going to, again, make our lives a little bit easier and copy paste this down there. You don't have to do that. You can just write them on your graph. I'm fine with that. All right, so we're going to go ahead. We're going to graph negative 2, negative 1/2. So we'd end up right there. We get 1, negative 1. 0 is undefined. Then we get 1, 1, and 2, 1/2. All right. Now, just looking at this, it's like, well, how does this end up looking? We could also graph this on Desmos. And actually, let's go ahead and do that. So we just have 1 divided by x. All right, this is what you end up with. All right, this is what this graph is going to look like. So we could go ahead, draw this side in, and it fit that prediction, right? We said we're going to have part of the function in that first quadrant. We're going to have part of that function in the second quadrant.